Hello and welcome to our Building Energy Codes seminar series. The series is based on our National Energy Codes Conference, which is hosted annually by the U.S. Department of Energy. We're here to present you with the latest in building energy codes, from developments in the model codes, to updates on what's happening across states and local governments, to highlighting tools and resources that you can take advantage of in your day-to-day practice. We'll be hearing from a number of leading experts about the challenges they're facing, ways they're working to solve them, and how their efforts are building the energy efficiency, comfort, quality, and affordability of America's homes and businesses. Join us virtually every week for important topics and interactive discussions, and help us continue the conversation. To learn more, visit energycodes.gov.
Welcome, everyone. I'm Ian Blanding with the Pacific Northwest National Laboratory, and I'd like to welcome you to today's webinar based on the National Energy Code Conference Seminar Series. Today's seminar will cover what's new in the residential provisions of the 2021 IECC. Looking ahead for the seminar series, we actually have a special edition seminar that is coming up next Tuesday, November 24th. This will cover energy codes around the world, and it's actually a NECC and International Energy Agency's Energy in Buildings and Communities, EBC, joint webinar. They're going to take a tour of energy codes around the world and hear from some of the 15 countries participating in the International Building Energy Codes Working Group. So just to note, and we've noted here on the screen, this session starts at 10 a.m. Eastern. So in order to accommodate all different time zones, we're starting a little earlier in the US. So 10 a.m. Eastern time, not 1 p.m. Eastern as we've typically done for these series. And then outside of that, after the holiday, then we'll get back to kind of our regularly scheduled programming, starting on December 3rd, looking at advanced technologies and codes, policy for energy efficiency and resilience, and then field studies in the Northwest region. And so to learn more and to register, go to energycodes.gov. The link is down here below. Before I kind of introduce our panelists, I wanted to do a quick couple polls just to get a sense of kind of who's in the audience. So if you'll bear with me, if you can fill out this first poll, kind of in which region are you located? Would love to get some feedback on that. Okay, we'll close the poll and then share the results. So it looks like you know, kind of a mix, but a good representation from the Northeast, and then kind of equal representation from Midwest, Southeast, Southwest, and West. So thanks for that. We'll move to our next poll, asking about which profession most closely aligns. So if you can fill that out. All right, we'll close and we'll share. So good representation of architects and engineers, nonprofits / consulting groups, code officials, plan reviewers, third-party verifiers. That's all great. And then some kind of public organizations, universities, federal, state, and local governments. So thanks for that. So now we will introduce our panelists. So first up, we have Rob Salcido, he's a senior building energy research engineer for PNNL. He joined PNNL in March of 2020. He leads the residential energy codes program at PNNL and is responsible for the advancement and development of residential energy codes. In addition to residential energy code work, Rob is a member of the ResCheck and ComCheck software team. And then prior to joining PNNL, he was the principal with Salcido Solutions, a consulting firm specializing in software design, building science, energy modeling, and building energy analysis. He has a bachelor's degree in environmental resources engineering from Humboldt State University in California, as well as a master's in civil engineering from the University of Colorado at Boulder. He's also a registered professional engineer in Colorado. We also have Todd Taylor, who recently retired from PNNL and is now a consultant. So he's kind of representing PNNL and has agreed to share his vast experience and kind of historical knowledge of the program and of residential energy codes. So Todd has 35 years analyzed and developed residential building energy codes, including the IECC, ASHRAE 90.2, federal standards for manufactured housing, and various regional codes and beyond code programs. He specializes in large-scale building simulation, economic analysis, utility grids, and analysis of large energy data sets. So thanks to both of you for being on today. So now we will kick things over to Rob. Let me change the presenter here for you, Rob.
All right.
So you should now have control.
Can you see my screen okay?
Yes, we are seeing your screen.
Okay, great, thanks Ian. And thank you everybody, and welcome to this webinar today for What's New in Residential Provisions of the 2021 IECC. My name is Rob Salcido, I'm with PNNL, and I'll be leading you through the webinar today. Todd Taylor will be assisting me at the end with questions and answers, and probably will be critiquing this at the end, so hopefully I'll do a good job in his eyes. So here's what we have in store for today. I'm going to go through a little bit of the overview of the IECC structure. Many of you may already know this and are very familiar with this, so we'll have just a brief overview, just in case anyone is not as familiar. And then we'll go over the summary of what's changed between the 2018 and 21 IECC. There's been 118 approved changes that will go into the 21 IECC. Actually, 4 have been removed on appeal. So actually, there will be 114 approved changes going on in the new code. I was considering having a painstaking discussion on each one of these, but I don't think I would finish before your Thanksgiving turkeys got cold. So we'll just go over those briefly, and then we'll show kind of the spread of what the changes are in the administrative, from energy related, based on their impact, and then we'll get into a little more detail in focusing on the components, what changes affect what components in the building, from envelope, lighting, HVAC, service hot water, performance-based approaches, and the appendix RB that describes zero energy homes. So we'll go from a very high level view down into more specifics as we go along. So let's start with the structure of the IECC. So the first question is, why do we care about the IECC? What's important in this realm? And so what it does is it guarantees a minimum level of efficiency in new buildings and renovated buildings. So it ensures that we can see energy reductions, energy efficiency improvements, as well as emission reductions over the life of the building. Energy codes are a subset of the building codes, which describe the requirements for building construction. And there's a additional cost benefit with codes is it's much more cost beneficial when we build in energy efficiency at the beginning of the cycle in the construction, as opposed to bringing in high efficiency in an existing building. It's much more costly. So if we can guarantee that the efficiency is designed and built into a new building, then it's much more effective in the building lifetime. So we look at commercial and residential sections of the IECC, and we have similar chapters. We have a chapter for the scope and application, administration and enforcement, and definitions. We have general requirements, and then we have the efficiency chapters, and this is where a majority of our discussion will land in today, which defines how to comply with the energy code and the different pathways that you could choose to show efficiency compliance. And then there's a chapter for existing buildings. Chapter 6 is for reference standards that are listed within the chapter 4, and then appendices and the index. So this is kind of the structure and outline of the code overall. but we'll specifically be looking into Chapter 4, which is, again, describes the compliance paths. So talking about Chapter 4, this is where we get into details on compliance pathways. First one is the prescriptive pathway. It describes the prescriptive requirements of the envelope itself. So this will describe what the roof insulation, the wall insulation, foundation insulation R values or assembly U factors are to be. It also lists out the U factors for windows, doors, and skylights, the solar heat gain coefficients for the windows, and air leakage and duct leakage rates. So these are listing the prescriptive requirements, and I'll talk a little bit more about a little more detail of the pathways as we go along. But this is where the prescriptive requirements are described. There's another section of Chapter 4 that describes more performance-based alternatives to compliance. One is a performance compliance, which looks at annual operation of the home. And then there's the energy rating index, which is kind of a asset rating that describes the energy efficiency of the building itself. So there are specific ERI ratings that a home must reach in order to show compliance. And we'll get into a little more detail here shortly. And then throughout the chapter, it describes mandatory requirements. And these are requirements that cannot be traded off. They must be met in their entirety or the building will not comply. Even it could be the most efficient building, showing the performance is well under compliance or the prescriptive requirements are very good. Unless these mandatory requirements are met, the building will not show compliance. So we got infiltration control, duct insulation and sealing, HVAC controls, piping and insulation, equipment sizing, dampers, and lighting. So all of these will have applicable mandatory requirements that need to be met. And so some terminology I'll be throwing around throughout the webinar is first is prescriptive. And these are component-specific requirements that can or cannot be lessened or eliminated in trade for compensating improvements elsewhere. So I'll talk about in the next slide where there are prescriptive requirements that are absolutely mandatory to be met, and there are some that could be traded off in other places within the envelope. The performance in ERI, the Energy Rating Index compliance paths, these take the annual performance of the home and compare it to a standard reference home. Now this standard reference home is primarily set based on the prescriptive requirements and some operational requirements in the code itself. So we're comparing a home on an annual performance between the design and the standard reference. And then again, like I said earlier, the mandatory requirements, these cannot be traded down in a compliance path. So these are absolute mandatories that must be met. And one thing I'd like to note when we talk about performance path is, as I mentioned, the performance path is taking the design home and comparing it to the standard reference home, which is based on the prescriptive requirements of the code. The ERI path is comparing the design home to a standard home that is part of the ResNet Standard 301 that is based on that code. That standard is based off the 2006 IECC. So your design home for the ERI is compared to more of a 2006 IECC level home to come up with the ERI rating. So we'll talk a little bit more about the pathway, the compliance pathway options. So there are actually 3 options within the prescriptive requirements that you can show compliance. One is an R value prescriptive requirement. So basically, this is saying that your R values in your envelope meet the prescriptive requirements, point blank. If they do, great. If one envelope component does not meet that R value, the building does not comply. So it's a very easy to show compliance with this. You can have it in a hand checklist or a spreadsheet. You can show that the home meets the R values and the home complies. There are U factor and UA trade-off possibilities where if you're looking at the U factors of the envelope, you could trade off assembly components within that component U factor. So in the walls, you could create any wall assembly, but as long as the U factor for that wall meets the U factor requirements, then that wall complies, but it must be all through the building. So the walls, the roof, the floors must meet the compliance U factor. There's a UA trade-off compliance path as well. This gives a little bit more flexibility where you can trade off UA values between envelope components. So you may have a wall insulation that may not meet the prescriptive requirements, but you have a roof insulation that's well above the prescriptive requirements. So the UA for your ceiling, you can trade off some of that benefit to the walls, and as long as the building UA, your design building UA, is less than or equal to the UA of the standard reference home, then that building will comply. So coming over to the simulated performance compliance path, which adds a little flexibility in your design, this is taking, now we're, instead of just a compliance checklist, we are looking at actual annual performance. So this requires code compliance software to model your design home and compare that, it should compare that design home to a standard reference home, which is based on the prescriptive requirements, as well as operational performance requirements that are set in the section R405 for the performance-based approach. And then it will take the annual energy consumption or cost of your design building, and it must be lower or equal to that from the standard reference design. So as long as it's lower, that lower cost, then this building complies. So you have a lot of trade-off flexibility within the simulated performance path, because you can maybe have a really high-level envelope, and maybe you have a little less on your air leakages, or you can trade off performance. So there's a lot of flexibility here, and this accounts only for space heating, space cooling, water heating, and ventilation energy. This does not account for any kind of lighting and appliance loads, just for those regulated loads I mentioned. Also, renewable energy cannot be used to boost the performance of the design building, so that is outside the parameters of the simulated performance. And finally, we have the ERI, the Energy Rating Index Compliance Pathway. So what is going on here is your design home, similar to your design home for simulated performance, is going to be compared to the ERI reference home. The ERI reference home is based on the standard 301, the resident standard 301, which is similar to the 2006 IECC home. So you're going to get a score based on the 301 standard has a methodology based on the normalized modified end use loads, which helps with fuel neutrality, has a process to calculate the ERI based on the design home. So the ERI is going to be a value from 0, which represents a zero energy home, from 100 to 100, which represents a 2006 IECC compliant home. So any code within there is going to have a lower than 100 score. So the lower the score, the better the home. And the 2021, all the IECCs, they have specific ERI requirements to show compliance. So if your home has an ERI that's equal to or lower than the ERI targets within the code itself, then this home complies. So where this design flexibility increases is now the ERI does account for lighting and appliances where the simulated performance does not. So you could use high efficiency lighting and appliances to trade off to get a better ERI rating. In addition, you can use renewable tech energy, on-site renewable energy, to boost your ERI to show compliance. So again, going from the prescriptive level up to energy rating index, there's more complexity in showing compliance, but there's also more flexibility in showing compliance. So I think, Ian, you wanted to do another poll right here?
Yeah, we got a couple more polls. Let's see if I can launch them. There we go. So if you guys can fill this out, just trying to gauge level of experience with the energy code, and then we have another poll after this to determine which energy code is in effect in your jurisdiction. So I'll give it just a couple more seconds here. All right, close that and share it. Yeah, so good good audience, I think, for this this discussion, and good background information that Rob is covering for some of the folks that have only been in the energy codes world for 1 to 5 years. But it looks like we also have you know, some more experienced folks on the line as well. So that's great to see. And so bear with me, we'll just do one more poll. And this is, as I mentioned, related to which energy code is currently in effect in your jurisdiction. And, you know, understanding there are amendments that have, you know, been incorporated, but, you know, which base code essentially is in effect. All right, give it just a couple more seconds here. All right, and we'll share the results. That's great. Somewhat surprising on my end. Great to see that, you know, the newer codes are really in effect, at least for those that are in the audience. Hopefully, you know, some of those jurisdictions are also now considering the 2021 IECC, so staying on that update cycle. So Rob, hopefully that provides some additional context for you as you continue through your presentation.
Thanks, Ian. Is my screen still up?
Yes, we can see it.
Okay, great. Okay, thanks for that. And so continuing on, just with hopefully somewhat of a better understanding of the structure of the IECC, we can now focus on what is going to be coming in the 2021 IECC. So, as I mentioned before, there are 114 accepted proposals for the 2021, and they range from, as you can see, there's 58% are administrative, and then the rest have some kind of energy impact. And we've rated these impacts based on a combination of our professional judgment as well as what is accounted for in our established methodology to determine the impact of these proposals. So this kind of fits into we'll talk about at the end, as our determination study that we use to determine what is the overall impact of the combined proposals on the overall energy efficiency of the 2021 IECC. So as you can see here, 66 administrative changes to the standard, which, as you can see, a majority of them are editorial, process changes, clarifications, definitions, adjustments, and amendments. So these really don't have much of an energy impact, but are kind of clarifications and updates to the code. You can see I've highlighted two in red over here, RE 147 for electric readiness, and the one for EV charging and readiness. These two were removed on appeal by the appeals board, so those will not be part of the 2021 IECC standard. These sets were deemed to have either minimal energy impact or possibly increased energy consumption. You know, when you think about this minimal impact or increased energy consumption, there could be arguments that, you know, in certain cases that these could possibly decrease energy consumption or maybe have more of an impact. But like I said, based on our established methodology, this is where these proposals fit into place. And we'll be discussing quite a few of these as we move forward. And then finally, we have 24 proposals that will definitely be decreasing energy. And again, I'm showing two here. One that bans continuous burning pilot lights, and the other that increases hot water efficiency. Those were removed on appeal as well. So we ended up with 24 proposals that will be going into the 2021 IECC that will help reduce energy, basically increasing efficiency. So without further ado, let's look at kind of the components themselves of the buildings and see what's going to be changing. So RE29, basically this says increase R value of the wood frame insulation in climate zones 4 and 5. And so you can see here, basically adding R5 insulation to the sheathing. So as opposed to 20, there's 20 plus 5 or 13 plus 10 for the climate zones 4 and 5. So this will definitely, in those climate zones, help increase energy efficiency. And then for slabs, we got some new slab insulation requirements. One being for climate zone 3, previously there was no requirements for slab insulation in climate zone 3, and now there's added in R10 at 2 feet of depth for perimeter slab insulation. While in climate zones 4 and 5, they've kept the insulation the same at R10, but now increased the depth from 2 feet to 4 feet. So matching up what's in climate zones 6 through 8 for those. So that will definitely help in the heating season for the energy consumption. Might show, especially in climate zone 3, might show a little increase in cooling consumption, but overall there'll be a total energy reduction there. So for ceilings, we've got 2 proposals affecting different climate zones. So for climate zones 2 and 3, we're going from an R38 to an R49. And then in climate zones 4 through 8, we're taking it from R49 to R60. So definitely increases that will benefit the energy consumption. So most all climate zones except climate zone 1 will be shifting in the 2021 IECC. So then we've got 3 proposals that affect the window requirements. As you can see, we're in climate zone 2, we're going from a U factor of 0.4 to 0.35, and then in climate zones 3 and 4A and B, going from 0.32 to 0.3. So definitely improving the stringency of the window U factors. We're also, for RE37, is adding a solar heat gain coefficient requirement of 0.4 for climate zone 5 and 4C. And then there's another requirement down here which is possibly has an energy impact of increasing energy consumption, where we're specifying that an allowance of a U factor of 0.32 in climate zones 4C up to 8 for homes above 4,000 feet in elevation or in windborne areas. You can have a U factor of 0.32 rather than 0.3, and this is just for in those harsher climates, it's hard to get lower U values, especially based on the pressure differentials or the structural protection for these windows. So that's where this one was, the reasons behind this proposal of allowing a U factor of 0.32 rather than 0.3 in these locations. And this one, this is where we're excited that we have backstops for windows in the code, and this is one of the mandatory requirements, where even though you have prescriptive requirements for the windows and allowing for trade-off, that you still have to meet a maximum U factor, an area weighted maximum U factor or solar heat gain coefficient. So in climate zones 4 and 5, it's going from 0.48 to 0.4, and then 0.3 from 0.4 to 0.35 and 6 through 8. And then in the skylight, for the windows, the solar heat gain coefficient is going from 0.5 to 0.4. So this provides a mandatory backstop for your windows. And the reason behind this is, since in earlier codes, this hasn't changed at all. While U factor, prescriptive U factor and solar heat gain coefficient requirements have dropped over the years, so they've improved, but this backstop has remained the same for all these years. So this change effectively kind of better aligns the backstop to what the current prescriptive requirements are for U factors and solar heat gain coefficients. So this one has been in its time coming. And these two, there were two proposals that kind of added additional assembly possibilities for the walls and basement walls. So originally, you could use a R15 continuous installation or an R19 cavity installation, and you still can, but now we've added a possibility that you can use R13 cavity installation combined with R5 continuous installation. So this is in climate zones 4C through 8 for the basement walls. It doesn't really affect energy consumption, just gives different prescriptive allowances for different assemblies. And the same with the wall requirements, where here it's gave an option that you could have 0 cavity installation and provide all your insulation on the sheathing or exterior, so it's continuous insulation. So this provides just different options that you could use in the prescriptive performance for showing compliance. Another envelope change is for under the performance compliance. Now that it allows infiltration to be at 5.0 ACH50, so it allows trade-offs based on your air leakage in the design home. So the prescriptive requirements, if you're going through a prescriptive performance path, you still, if you're in climate zones 3 through 8, you still need to meet the 3 ACH50 infiltration requirement. But if you're going on through a performance path, you can, as long as your home is greater than less than, thank you. As long as your air leakage is less than 5 ACH50, the home will comply and meet the requirement. And it allows the design home to get trade-off credit for lower infiltration, for tested infiltration. So if your design home had a 3 ACH50, you could use that benefit to trade off with other components in the building. So you might have a little less envelope efficiency that could be covered by the better, tighter home. So your infiltration could gain that credit. So just the important piece is if you're doing the prescriptive compliance, the air leakages have not changed. So those were the envelope changes. We'll go through some of the lighting changes that you'll see in the code. So there were two proposals, RE7, RE145, that increased the efficacy of in the definition of high efficacy lamps. RE7 specifies that lamps must have 65 lumens per watt and keeps the percent of lighting at 90%, maintaining that 90% of your lighting must be consist of high efficacy lamps. Where RE145 states that the lamps shall be 70 lumens per watt and that all lighting in the home will be high efficacy lighting. So it'll be interesting when the published version of the 2021 IECC comes out, how they combine and harmonize these two proposals to come up with final language. So to be determined. And then RE148, this specifies that all exterior lighting in low-rise multifamily buildings must comply with IECC section C405.4 for exterior lighting. So this just governs the allowances for exterior lighting based on location. So it specifies areas like parking, facade, entryways, etc. So this now has allowances for based on where the exterior lighting is located. And then for RE149, exterior lighting controls, this is basically mandating that any connected permanent exterior lighting greater than 30 watts must have some kind of control, be it you can pick one of the 4 of a manual on-off switches with automatic shutoff, photo sensor controls, a timer switch, or any kind of automatic shutoff that allows an override so that it returns to normal operation within a 24-hour period. So these are the lighting changes. Definitely these will help reduce energy consumption in lighting. The RE148 it'll be to be determined if that's true based on what the lighting was before and what requirements are now for C405.4. So that I could see arguments that could go either way. And now we'll talk about some HVAC changes in the 2021. So in the past, duct leakage testing, it was always an exception. If you had ducts in the conditioned space, that you did not need to duct test those ducts. That exception has been removed. So now, no matter where the ducts are located, they will need to be tested with a duct blaster. And the reason behind this is that even though all the ducts may be in inside conditioned space, and there wouldn't be probably zero to very little duct leakage outside, that could be comfort issues. If you have installed very leaky ducts inside the space, that the spaces on the far end of the duct run will not be getting the required airflow, and there could be comfort issues. So the argument here is that this will reduce callbacks and improve comfort and balancing within the building itself. So it's a performance and comfort issue. Probably will not have any energy impact or minimal energy impact, but this will probably affect builders and those who do the duct testing, that now they will, where they usually had the exception, now they're going to be testing those ducts. So I think it's a good thing that this is in place. Then we got some mechanical ventilation requirements. RE 130 now mandates that, or in the code, that mechanical ventilation systems shall now be tested and verified that they provide the minimum flow rates based on the building itself. So there will be some kind of a verification that the mechanical ventilation systems are meeting those minimum flows. We also have some increases to the efficacy based on the type of fan. So inline fan went from 2.8 to 3.8 CFMs per watt. Bathroom fans, based on the flow rate, went from 1.4 to 2.8 CFM per watt. And then if it's 90 or above, then it went from 2.8 to 3.5 CFM per watt. So increasing definitely help reduce some energy consumption there for ventilation fans. And then also there was a newly added section for integrated air handlers as part of the air cycler systems, that these must meet 1.2 CFM per watt. So RE 139, now for prescriptive path only, it's going to require the mechanical ventilation in climate zone 7 and 8 are to be provided by an HRV, a heat recovery ventilator, or an energy recovery ventilator. There was a study done at PNNL that showed that these units can be cost effective in climate zone 7 and 8. So that was the reasoning behind this proposal, and it was accepted. So this will definitely, for those two climate zones, having an ERV or HRV over a standard supply only or exhaust only will definitely help reduce energy consumption for the ventilation piece. So those were the HVAC changes. Now we'll look at the service hot water changes that'll be going into 2021 IECC. And this, so RE 162, so this proposal adds a compactness factor to the performance path for hot water usage. So in the past, basically the only way to show energy savings in the service hot water was to have a high efficiency hot water heater. And now, and there was no way to incorporate compactness of design, or just how central or in the case of how centralized was your water heater in relation to the fixtures in the home. So now this kind of incorporates benefiting compact design in the home for a compact water distribution system, as well as having a centralized hot water heater. So the original equation for determining what is the hot water demand on a daily basis was the standard, 10 times the number of bedrooms plus 30, and that would be your gallons per day for the home. So in the proposed design, we're going to adjust that equation by incorporating the compactness factor. So here it shows various levels of the compactness of the distribution system. The higher the compactness, obviously there's no benefit, but as you become more and more compact in your design based on your home, then this factor will come into play and reduce the gallons per day in your design home, so you can show savings of this in the performance path. So we'll talk about, here's how you specify the compactness factor. So first thing is you locate the water heater, and that's signified by this red dot. And then you draw a rectangle through the center line of the water heater and the plumbing fixtures along the wall. So in this case, since we've got a fixture along this point of the wall and in the kitchen along this wall, the square is going to come outside that water heater. So that's the reason it's not through the center line of this water heater. But this is your area of your hot water distribution system. So we calculate the area of this square, this rectangle, and then we're going to calculate, we know the area of this conditioned floor area, so you're going to divide this compact area by the total area, and that's going to give you your compactness factor. And then you can see, is that low enough to take advantage that you can calculate that your proposed design will have a lower hot water consumption in the gallons per day. So I can show you where this could look, how this could benefit. So let's take the case where we have, and I apologize if these aren't super clear, but you'll get the idea, is we've got a home where the water heater is at one corner of the garage, and we draw the square that encapsulates all the hot water distribution system. So in this case, we have 1,147 square feet of floor area in this home, and our hot water system rectangle is 828 square feet. So dividing that 828 by 1147, we get 72% compactness factor, which we don't get any credit for that. It's just too high of a compactness, so it's not going to get credit. Now, if we want to just move that water heater to the other corner of the garage where it's closer and makes it more compact and centralized, now we have the same square footage in the conditioned floor space, but now we have 575 square feet of this smaller rectangle. So now our compactness ratio is 50%, and we get 5% reduction in our hot water usage. So we can take credit for that in the performance path. So this proposal will really help incentivize this compactness of this whole hot water distribution system. So another proposal that's similar in scope and in effect towards the hot water consumption is just adjusting the equation for hot water gallons per day. In the past, like I said, it was 10 times the number of bedrooms plus 30. Now it's 25.5 plus 8.5 times the number of bedrooms. So this is basically probably a 15% reduction in hot water gallons per day for the proposed home. And it is the same in the reference design. So while this shift will reduce the consumption for hot water, it's going to be the same for the standard design as well. So there's going to be no real benefit. You're not going to get credit for this because the reference design has the same hot water demand, but it does shift down the overall energy consumptions for both designs. It makes that a little more closer to actual design schedules or hot water schedules in homes. And this equation has not been updated since 1996. So, sorry, 1998. So it's good that this is becoming more realistic with what homes are seeing as far as hot water consumption. So let's talk about some performance and ERI changes. The big one here is that the climate zones will be shifting. So as you see on the left here, this is the climate zone map we've also used in the IECC for some time since its inception, and it has climate zones 1 through 8 spread out throughout the country. And in ASHRAE 90.1, 90.2, we're using the climate zone map out of standard 169/2013. So the result of this was there's a 10% of the climate zones in the country had were in different climate zones. So let me say that again. 10% of the counties in the U.S. had different climate zones. So with the IECC adopting 169/2013, we're going to be using this climate zone map for the performance approach in the annual performance analyses. So you can see here that there's some new climate zones. We have climate zone 0, which basically aren't in the US, but those are extremely hot climate zones. But there is an additional, there's climate zone 5C, which is a new climate zone for cool marine. And that is basically up here in the Seattle region for that climate zone. So what this shift essentially does is there's a lot of counties in the country that will be shifting to a milder climate zone. So basically, it's going to have less stringent prescriptive requirements in those areas. So as you can see, the greens represent counties moving to colder climate zones, and the reds are counties that are moving to warmer. So the green counties will have higher prescriptive, more stringent prescriptive requirements, while the red counties will have less stringent prescriptive requirements. So this will play into what is the effect of overall and a national level of what is the impact of the 2020 IECC. On the ERI side, there's 2 proposed backstops. The first one, RE 150, is setting the ERI envelope backstop to 115% of the 2020 IECC reference UA. So earlier on, we talked about for a UA prescriptive approach that the proposed design of the UA of the proposed design must equal the UA of the prescriptive design, and then it complies. Well, in this case, just as a backstop for the ERI, we're allowing the 15% boost on the prescriptive reference design. So this is just a backstop in the ERI compliance path, that making sure that the envelope meets this backstop, that it's within 15% of the prescriptive reference design UA. And there's also a secondary one from RE 182 that sets the backstop to the 2018 IECC when using on-site renewable energy. So if your design home has on-site renewable energy, then the compliance, the backstop for the envelope, so it's basically saying the UA of your proposed design must equal the UA of the 2018 IECC prescriptive design. So again, there's a lot of overlap on these. It'll be interesting to see how the final version of the 2021 IECC melds these 2 together to come up with either a dueling or a single envelope backstop for the ERI. Another another envelope backstop is for the performance path. So this is the first time that the performance path will have a backstop. In previous codes, there was no backstop in the performance path. So you could have a poor envelope and cover that with other efficiency values within the building design to meet the requirements. In this case now, the envelope backstop is the 2009 IECC. So typically in your performance software, you're going to do a UA check, where making sure the UA of the proposed design meets the UA of the 2009 IECC. That's the simplest way to show that kind of compliance. So this will be, so now the envelope must meet that level of stringency to the 2009 IECC. In the performance path now, there's a section in table R405 that specifies humidistats. So starting to think about latent loads and latent load recovery. So this is setting humidistat requirements for the reference design. And also in the proposed design, these are the very same requirements that it must meet. So similar to what I mentioned earlier with the hot water, where it was the hot water demand was changed in both the proposed design and reference design. Similar here, where you're going to have similar settings for the humidistats in the proposed and reference design. So this is bringing into account now that the whole annual energy consumption will be accounting now for the latent loads in the house. So I think right now this will help encourage software providers, compliance software providers to account for the moisture in the home. So I think we'll see future advancement of this in future energy code cycles. And another that accounts for the ERI is that there's now going to be a cap on how much renewable energy that can be used in the ERI calculation. In past cycles, you could have a standard home, a substandard home, anyway, and that maybe may not meet the performance requirements, the simulated performance requirements, but then we could just throw on, a huge PV system, and that home would then comply in the ERI pathway. So this sets now kind of a cap on renewable energy to 5% of total energy use. So this kind of helps ensure that there's a good envelope and HVAC and air leakage design in the home, and not relying completely on renewable energy to lower the ERI. So this places a limit on how much credit that on-site renewable energy can provide. And so in the 2021 IECC, the ERI targets are going to be set back to the 2015 ERI targets. So if you look at the 2015 levels, these are from 52, 54, 55, 53. So we're setting the 2021s back equal to those values. The 57, these numbers were what was in the 2018 IECC. So the scores were increased because the changes in the code that reduced the ventilation requirements in the ERI reference home, and so in so doing, the result of that was that they increased the ERI scores significantly. From it could be 5 to 10 points in some cases, and so it made it harder to get down to the level of the 2015 ERI targets. So now that the 2021 IECC is going to be set back to those targets, it will prove it'll be harder to meet those targets with the ventilation requirements of the reference home intact. So that'll be interesting to see how many will be meeting, how many homes can meet those 2021 ERI targets. And so another big proposal that's going to help increase energy efficiency is RE209, which is adding in additional efficiency option packages. So this is similar to the commercial IECC portions of the code, where there are options that are required to be chosen that would increase efficiency of the building. So in this case, there are 5 options that the primary goal is to increase efficiency of 5% beyond the prescriptive requirements. So option 1 is an enhanced envelope performance option, where basically the design UA now has to not only just meet the standard UA, but has to be 5% below the standard UA. So 0.95 times the standard UA is the requirement. Option 2 is efficient HVAC equipment performance, where you have a furnace of 95% AFUE or better and a 16 SEER air conditioner or better. or an air source heat pump with a 10 HSPF and 16 SEER, or a ground source heat pump of greater than 3.5 COP. So option 3 could be a reduced energy in your server's hot water. So you're having higher efficiency water heaters, 0.82 EF for oil or gas water heaters. Electric must be 2 or 2.0 EF or greater, which is probably a heat pump water heater level, or a solar water heater with greater than 0.4 solar fraction. You can have gated in option 4 for more efficient ducts. So basically, that 100% of your ducts are inside the building thermal envelope or inside conditioned space, or you have a ductless or hydronic systems, so no thermal distribution. And then the final option 5 is improved air sealing and efficient ventilation. So as long as your air leakage is below 3.0 ACH50 and you have an HRV or an ERV with either 75% sensible recovery efficiency, or for the ERV, 50% latent recovery, moisture transfer efficiency, then you've met the requirements. So picking any one of these 5 is mandatory. It is not something that can be traded off, but you need to prove that your home has one of these 5 options. And then finally, Appendix RB for a zero energy home. This is basically allows jurisdictions to adopt a model and a standard for zero energy home designation. So this is not a requirement unless a jurisdiction adopts and makes this appendix part of their code, then this would be a requirement. So basically it shows the pathway to prove that this is a zero energy home where you have 2 ERI scores based on your climate zone. So you'll have a ERI without on-site renewable energy. So this is basically reflecting that you must, based on these levels in the 40s, that you have to have a very efficient design in your home. The envelope, the mechanical systems, they're airtight, efficient lights and appliances, and you first meet these scores, and then you supplement that with enough PV that your final ERI is a 0. In that case, excuse me, in that case, then you have truly a zero energy building based on these requirements. So if a jurisdiction does not specifically mandate or accept this part of the code, then it is not required. So those were all the changes that we felt have the most impact on energy consumption. As you can see, if you look at this map here, the percentage of state populations that are going to be moving to warmer zones based on the climate zone changes, you can see, North Dakota, Texas, North Carolina, Wisconsin, these are the ones that are going to be seeing the major shifts, most shifts based on population areas and population density where these climate zone shifts occurred. So this will be interesting to see a final result when we do our final determination study to see what is the overall impact on the 2021 IECC. And we have plans to implement the 2021 IECC into our ResCheck and ComCheck software next year, in the spring for ResCheck and in the fall for the ComCheck software. So keep an eye out for those. And with that, I will take on any questions that you have.
All right, thanks for that, Rob. Let me just take control real quick. And while I do that, please continue to put questions into the question bar. So we do have a number of questions that have already come in. So let me start going through those. Okay, so let's start with kind of the development process of the IECC. There's a question on how do you access the residential amendments that were submitted kind of prior to the 2021 IECC publication. So where can you find those proposals that were submitted?
Todd, are those? I imagine those are on the IECC website in the code hearings section.
Todd might not be fully online yet. Todd, it looks like you're muted if you're trying to talk. There he is. There we go.
Okay, are we better now?
I can hear you. Yep.
Oh, good.
Okay, yeah. The ICC website is called iccsafe.org. ICC is all about safety, so iccsafe.org. And follow the menus through the code development section, and you can get all of that information for multiple code hearings going back through the years even. So yes, it's all out there. It's quite voluminous.
Excellent. Excellent. And then there's also a number of questions about whether or not the slides are available. They are available at energycodes.gov, and I will put that link into the chat, but they are currently available. Let's see, next question. So this is Windows, and Rob, you might not be able to answer this. I can potentially help out if possible. Windows DOE project to issue a determination on the 2021 IECC. So Rob, any thoughts? Otherwise, I've got at least
Can you
general
ask the
idea.
question? You kind of broke up a little bit.
Oh, sorry about that. When does DOE project to issue a determination on the 2021 IECC?
Oh, we're hoping that will be coming out in probably, I'd like to say the March timeframe. But we need to wait for the published version of the 2021 IECC to make sure that we account for what's in the actual published code. So the sooner that comes out, yeah, we can. But I think still in a March timeframe is what we're looking at.
Okay. Yeah, and I'll just note that statutory timeline is 12 months from when the ICC code has been officially released. So it's hopefully at least going to be within that window.
This is Todd. I'll just comment on that. The March timeframe that Rob is referring to will be an initial draft, and there will be an opportunity for public comments on that. And then the final, I would generally, you can expect the final is pretty close to that 1 year timeframe. It's hard to fit the comment period in there with any shorter than that.
Yeah, good point.
Excellent. Next question, we'll move to the envelope section of the code. So for wall insulation, does a double stud wall meet the continuous insulation requirement, or must it be exterior insulation?
Yeah, but those, the continuous insulation requires, so imagine on a prescriptive level, I would imagine so. Without knowing any other details on it, if the continuous insulation, if it's unbroken by any studs, as long as that R value meets, I could say the minimum R value in that that's continuous in that wall should meet those requirements.
Yeah, I would say as long as there's staggered studs, in some way, and that is broken, I would think that would work.
Yeah.
This is Todd again. Generally speaking, if you're complying by the R value tables, you need to do what's in the table, but you're always free to go to the U factor table to build an equivalent wall that could be a double stud or whatever.
Excellent. Let's see. So another question on insulation, and we might, we haven't done any full modeling on the code yet, but the question is, in your opinion, does R60 in the attic represent optimal cost benefit, and at what point does adding more insulation and costs, outweigh the energy savings?
That's a good question. I don't know if I can provide a solid answer that, yeah, at some point, yeah, you will. At what point do you get to the diminishing returns where, you know, the cost of, you know, the cost is significantly to increase the insulation, but the energy consumption benefit is getting lower and lower. So I know that the proposal, the folks who did the proposal on it did some financial analysis, but we have yet to do our own in our determination study. So I don't know if I can define a definitive answer to say yes, 60 is at that. It might be bridging on that point, but
Okay.
I don't know. Todd, what do you think?
Haven't done the analysis, so we'll, you know,
We'll see.
can't answer until we do that analysis, and it's going to vary from place to place, obviously. So I would say the jury is still out analytically.
Okay, excellent. So moving on to lighting here. So there's a question on interior lighting. So Rob, you mentioned that there are the two kind of competing proposals that were voted in. The question is, would the more stringent proposal, RE 145, take precedence over the weaker proposal, RE 7?
Todd, you have experience with in these multiple proposals when they come out.
I would give a very solid, I don't know. We're anxious to see how ICC coordinates those two, but I really have no idea what they'll do.
Okay, excellent. Moving on to HVAC type of questions. So now that duct leakage is required, regardless of whether or not you know, it's inside or outside the thermal boundary, what is the duct leakage target for that now? If you could kind of reiterate what that is.
Oh, the duct leakage target remains the same. It's a total duct leakage test, so it's gonna based on, you know, if the air handler is installed or not. So based on the timing of the test, they remain. There's no change in those values.
Okay, so it's the values are remain the same, but it is prescriptive still, right? That can be traded off. Is that correct?
Mm-hmm.
Okay.
Yes.
Okay, moving on to water heating. It looks like we have a couple questions on that. So how is the hot water distribution compactness factor, I guess, analyzed if the hot water heater is on a different floor level than the fixtures? Does it also have a height component in that analysis?
It does. Yeah. There's in the footnotes of that table now there it describes that you add additional area. Let me see if I can find it real quick. Because I have it as part of some of my slides.
I could also potentially pull it up. Let me scroll out.
While Rob is hunting for the slide, I believe that it's the number of stories is accounted for separately from the size of the rectangle. Isn't that right, Rob?
Yeah, it's in the, yeah, you're right. It's in the table. 1 story versus 2 or more stories. So it has different compactness requirements.
So
Okay.
I think maybe the answer to the question is the rectangle is the same. You're just looking down on the building, but the
Right.
threshold that you're targeting differs depending on how many stories there are.
Excellent. Another question on water heating. For residential water heating, it appears the energy efficiency metric is measured in EF, when UEF is the efficiency metric for residential hot water heaters, and a DOE labeling requirement as of 2017. I guess that's the question is, is it EF in the code and UEF elsewhere, or how is that that labeled?
I noticed that as well, and I took the EF straight out of the proposal language, so there may need to be clarification when it comes to a published version. Did they mean the UEF, and that's what will be in the proposal, or do they have to kind of shift those to account for that it was EF, and what would be a corresponding UEF? But that is the language straight out of the proposal. So again, once we see the published version, we'll know for sure.
Okay, so there's just a couple questions. There was a few questions on when ICC, or when the 2021 IECC might be released. And so, based on ICC's website, it looks like it'll be available sometime in December. So there's some questions on given the appeals process and how that went, is that going to push back the timeline? But ICC is saying it'll be available sometime in December. And then Rob, I think you mentioned this, but just to reiterate, the question on when will ResCheck support the 2021 IECC desktop version, or if it will?
Yes, the goal is to in May of next year to have it ResCheck, and then in ComCheck by October. Those are our plans. We'll see. It's, those are our goals.
Okay, excellent. So there's still a question on what is the total duct leakage target. So the target is 4%. Is that correct?
Yeah, I just had that open and I closed it again.
I actually believe it's 4 CFM per 100 square feet at 25 pascals.
Yeah. Yep.
Okay.
So it'd be 3 if the air handler is not installed.
Yeah. Okay. Exactly. Any additional questions? It looks like we've gotten to all of them. Oh, hang on. There's one here that I apparently missed. Does the zero energy appendix allow offsite renewable energy generation to count toward the ERI score of 0?
It mentions only on-site energy. It does not say anything about off-site. So I would have to say no. And I mean, I know there's talk of in certain code cycles, I've heard discussions about allowing, where it becomes difficult is if you're in thinking of a multifamily building where, maybe there's just not enough room for on-site renewables, but there is applicable off-site. But at this time, looking at the language, it just mentions on-site.
Okay, excellent. So before I'll give a couple seconds here if anybody else has any questions, but I've got a question for Todd. So given your vast experience with the residential IECC development process, how does this year compare to previous years in terms of number of changes, level of improvement? And that is the jury's still somewhat out on level of improvement, given that we haven't done the analysis. But just curious if you have any sense on kind of how this year compares to some of the other cycles.
Well, this is a pretty big year, both in terms of the number of changes, and I believe we will find in the magnitude of the changes. Historically, there were some very large improvements in efficiency between 06 and 09 and between 09 and 2012. But since 2012, through 2012, 2015, and 2018 were very, very modestly improved. So those code cycles were small increases in efficiency. This one will be larger than those. Whether it compares to the 09 and the 012 codes in terms of improvement, we'll just have to wait and see.
Excellent. And then last question, one that came through, is PNNL or another entity compiling the costs and savings data associated with this code change? So Rob, if you want to speak to that a little bit.
Say that, ask it again, sorry.
So basically, is PNNL going to do a cost benefit of this code? So I mean, that's obviously something that we do, but I was hoping you could, I guess, speak a little more to it.
Yeah, as part of, we do, one of the analysis we do is a determination study, which just basically, what is the impact of the code itself over the previous codes. And so is it more compliant, are you more efficient, less efficient? And there's also, as part of that, is a cost effectiveness approach. So then we look at, of the measures that we incorporate into the study, what is the cost? And so we will be doing a life cycle analysis. So let me back up. What is the, the installation cost for those measures? How much does it increase the construction cost? And then we do a life cycle analysis based on that, with the cost savings based on those higher efficiency measures. So that we will be doing those two analyses.
Excellent. Last question before we wrap up. This is related to the performance path. Does the simulated performance method account for building orientation?
Yes, it would.
Okay.
So as long as the model accounts for that as well, the compliance software tool. So if it shows the, as long as it can orient it correctly and then take account for the solar insolation on the windows, yeah, it will account for that. It should.
Excellent. Right, yeah. Okay, well, I appreciate all the questions from everybody. Thank you to Rob and Todd for enlightening us and providing that great presentation. So just a reminder that the NECC seminar series is continuing, and we hope that you'll join us next Tuesday. Again, this is kind of a special edition, late edition to the NECC lineup, but you don't want to miss it. It's going to be kind of a combination of IEA as well as DOE, talking about energy codes around the world. And again, that starts at 10 a.m. Eastern, so hopefully you can join us for that. And then we have got a great lineup that goes back to our regularly scheduled Thursday at 1 p.m. Eastern after Thanksgiving. So with that, thanks again, everyone, for tuning in, and we hope that you will join us next time.
Thanks, Ian. Thanks, everybody.
All right, thanks so much.
This has been the National Energy Codes Conference Seminar Series, hosted by the U.S. Department of Energy. Join us each week for a number of other important topics in building energy codes, just like today's. We're here every Thursday afternoon at 1 p.m. Eastern. Participate live in our upcoming events, or listen to past events on demand through our energycodes.gov training portal. There you'll find other helpful tools and resources, from education and training materials to compliance tools like our ResCheck and ComCheck software, to the latest on state code updates, to analysis of energy code impacts, from energy savings to cost effectiveness, and more. Check out energycodes.gov for those and a number of other technical assistance resources from DOE, Pacific Northwest National Lab, and others. From the DOE Building Energy Codes program, we hope you learned something new about energy codes and enjoyed today's session. Thanks for being part of the conversation, and we'll see you next time.